and so on. IMEI is an active collaboration with international bodies like SNAME, IMR EST, CMMI, and a global partner with WMTC. Being a member of the Institute has its own advantages of developing a professional competency on a continual basis throughout one's career as a marine engineer. Access to relevant information to keep abreast of technical advances, changes to statutory requirements and current best practices in the marine sector, which helps with your learning and career progression. IMEI and TMI have been associated right from the inception stage of this institute and go a long way to have a mutually fulfilling association. This year's theme, Challenges and Optimization in Transport Technology, is quite relevant for getting a better understanding of the present day changed circumstances and solutions to be sought to make life better at sea for the students. I wish the seminar a grand success and my greeting and compliments to all the organizing team. Thank you.
Thank you, Mr. Chandakar. Now I would like to invite Mr. K.K. Ghosh, Chairman of Institution of Engineers, India, Pune Local Center.
Good morning to all of you. Respected Chief Guest, Guest of Honor, our keynote speaker, Principal Iyer Sir, Saxena Sir, faculty member of TMI and students. A warm welcome for that from the Institute of Engineers, Pune chapter. This Transtech we have associated with so many years, right from the inception, being a mentor of Dr. Saxena was the Institute of Engineers member and we have supported all. As far as Institute of Engineers Pune Local Center or IEI is concerned, it is the largest body professional organization having 2.3 lakh corporate members all over India. It has a pan-India existence. All over India it has a 123 centers and it is encompassing all the 15 engineering branches starting from civil, mechanical, electrical to computer, textile, marine, mining, metallurgy, all these. Basically it gives the students also, to improve the visibility, we have gone to the student level also, opening the student chapters and giving the grant in aid. And this year I am congratulating TMI to become an institutional member of the Institute of Engineers. And on the basis of that, we will definitely conduct so many this type of seminars because in association with the Institute of Engineers for the benefit of the students of TMI. So being this, as far as marine engineering is concerned, basically it is mechanical engineers. All this is there. I request all of you to write a research paper because Institute of Engineers is publishing the paper in marine branches, and we are getting short of paper, we are not getting any research. Because there are a lot of research to be done. Being a so much big transport carrier is there all over world, there are a lot of scope for research for energy efficiency. So I request all of you, those are budding engineers, now it is they will be representing all these paper in today's seminar, but I request our faculty member also to do the research in this way for that energy efficiency in the transport sector because there are a lot of scope available. So with this note, and one more thing is there, Institute of Engineers is giving grant in aid. So I request our principal Iyer Sir to send a proposal for getting the research and development grant as an institutional member from the Institute of Engineers to promote the research in the institution of TMI so that it will be benefited to all the students as a BTech project or as a faculty member, those who want to do the PhD. So they can also get the research and development grant from the Institute of Engineers. Being an institutional member, definitely it will be a priority given to this. every year these proposals are taken and grants are given, so that we will give you the research fund for getting you can have a big research topic and you can go everywhere giving a proposal, because only few proposals are coming from the marine engineering division. Others are mechanical, regular civil engineering proposals are coming, but for marine engineering proposals are not there. So my request to Principal Sir, Iyer Sir, to make a proposal related to the marine engineering and submit it to the Institute of Engineers by the headquarters throughout the year, so that you will get the grants and you can conduct the research at the degree level also as your BTech project also. Thank you for.
Thank you, sir. I would now like to introduce our guest speaker. Dr. Vishwas Ramakrishna Udpikar completed his BE in Electronics and Communication from University of Pune in 1981. He then completed his MTech in Electronics from IIT Madras in 1983. He further completed his PhD from IIT Madras in 1989. He is the founder director of Wavelet Technologies. He has also worked as the managing director at IFM Engineering and was also involved in image process application development in CDAC Pune. Formerly, he also researched and taught at IIT Madras. Presently, he is working as the director at SciComm Software. I now invite Dr. Udpikar to give his keynote address.
While we get the technology fixed, let me just express my enormous admiration to the way this event is organized. I think compliments to the TMI team. I'm seeing difference almost in every little detail. It's nice to see a very disciplined lot of participants here, all in place in time, starting on time. Wonderful. And Captain Kevin Mascarenhas in his opening remarks talked about emergency exits. So that was really something I have not seen in events of this kind. So this really shows the difference. And I really appreciate Transtech 20 to have invited me to give a talk here. I think you heard in the generous introduction of me, I did something in electronics. So obviously I'm connected more with communication and software, and a lot of what you guys do uses this technology. So hopefully there is a good connect, and hopefully I'll be able to tell you something that we've done in fields connected with you. The themes of Transtech that those were shown in the presentation. Again, compliments to whoever made the presentation. Very nicely summarized and very apt selection of themes. I think many of those are really extremely relevant. I mean, the statement that world of transportation is changing probably can be made from the beginning when the wheel was invented. But today I think we sit at a point where there are groundbreaking changes. All this EV, renewable energy, autonomous navigation, extremely high emphasis on emission standards, bringing safety and security. All these things are really taking a different level now. And as I think marine engineers, it will be very exciting for you to get a chance to work on some of these things in your careers. So what I'm going to do today is, I think there are two challenges or two themes from that presentation that are probably very relevant to SciComm's work. One is from the safety and security related more to navigation. And we had the chance to work on the search and rescue transponder of Indian Space Research Organization many years ago. And we are very happy to say that for the last almost 15 years, this transponder is working 24/7 using our receiver technology. And this is used for providing search and rescue support to different kinds of situations. Maritime, of course, is a very big component. And you probably all know that India is a very proud member of this international consortium called COSPAS-SARSAT, providing even the space segment. There are many countries that provide ground segment, but we also provide space segment thanks to ISRO. We have a number of satellites, and some of our satellites are designed with the objective to provide this kind of support over a very large area. So I'm told that our geostationary satellites cover almost from the tip of South Africa to Australia. And hundreds of search and rescue missions have been conducted using this transponder that is there with ISRO. The second theme I feel a little bit close with what was shown is all these new things, the AI, ML and automation, autonomous driving, autonomous navigation and so on. So SciComm works on a very interesting technology which is 3D imaging, and just as humans can see 3D, we have sensors that can see 3D, and they see 3D in real time. So that day is not very far where I think almost everything will be autonomous, like humans can look around and decide where to go and how to go. Machines will be able to do that, and consequently bigger platforms like boats and ships and aircrafts and drones and cars and whatnot, anything that's moving will get this ability. So I'll talk a little bit about that if there is time at the end. So just a very quick introduction to the different domains. I'll not take more than a few minutes to tell you about SciComm. But for the last 20 years, this company is in operation. It started as an image processing company, and image processing, as the name suggests, is something to do with images. And images is what we appreciate using our eyes. So it's something to do with vision. And there are various names with which you can call this domain. It can be called computer vision, machine vision, and so on. So we started with that, and our first problem was given by an American company. They are in the area of semiconductor wafer inspection. And some of you probably are introduced to the electronics technology, that these wafers are made with patterns that are as small as 10 or 15 nanometer. So the pen with which they write on this pattern has a tip of the size of 15 nanometer. So to do an inspection on this, if this pattern is right, it's beyond human vision. So you require automated systems, sensors that can really look at that resolution. Mind you, this resolution is below the wavelength of visible light. Visible light is below 400 nanometers. There's no visible light. So you're looking at features made by humans which are below wavelength of visible light, and you have to look at them very precisely so that there's no defect. Electronics technology today is such that if you buy something electronic, it has to work. Can you go to a shop and buy a cell phone, bring it home, and then it doesn't power up? Unheard of, right? The expectation of reliability is absolutely 100%. And this is possible only if these patterns and chips are made with this kind of inspection, that the pattern is exactly what it is and then the chip behaves the way it is. So we started with that. And over the years we assimilated a number of other signal processing technologies, so the domains are here. We work on electro-optics, a lot of laser range finders, we have worked on indigenous development. By the way, the motto for SciComm is to do something in India. With that idea, I started these companies that we can do high technology in this country. So all that I read here is completely designed, developed, manufactured in India. So the laser rangefinders, seekers, which are used in weapon systems, Q-switch drivers, which are again used in laser equipment, gyroscopes. I think gyroscopes are probably you're aware are used in inertial navigation systems and stabilization technologies. So we have developed a fiber optic gyro completely indigenously, and time of flight imaging. Digital communication, which is the main topic of my discussion today. It manifests as software-defined radio. I think when the topic of telecommunication is introduced, it typically starts with antennas and signals and frequencies and modulation and so on. The wonderful thing today is all that can be done by software. So you are not essentially pulling out soldering iron to build a radio. You are essentially pulling out a computer and maybe a compiler like a C compiler or a C++ compiler to build a radio. And this is the change that has happened in the last 15-20 years. So we do a lot of SDR, software-defined radio. In fact, I'm happy to say that one of our SDR applications is for Indian Navy. It's a multi-band radio that works different class of modulations and gives a lot of flexibility to Navy. COSPAS SARSAT is the topic I'll tell you a little bit more in detail. Search and rescue receiver, CDMA encoders, UHF transmitters, receivers for satellite communication. These are the things we work on. Another very big area we work on is radars, and the radars that we specialize in are wind profiling radars. Again, for your domain, I think weather plays a very important role. You have to know what is the upper air wind profile, because that decides the rainfall, it decides possibility of cyclones and hazardous conditions, and I think the extent of waves in water again depend on the wind profile and so on. So we built the first indigenous wind profiling radar. It's situated near Tirupati, and the complete signal processing and its electronics is built by SciComm's team. Again, last 20 years is working 24/7, and it helps flight guidance, satellite launches, and so on. And since then, we have done a number of wind profiler radars. So this is another area in which we work. IoT and smart security are the other domains. Now, what it takes to really work in these areas, if some of the young engineers here want to do also things in these areas, typically you need to know techniques of signal and image processing and video analytics. These are the theoretical foundations based on which my company's work happens. And then we need to know specific technologies like PLCs, microcontrollers, DSPs, FPGAs, server machines, and so on, using which we do our development. So the slide shows some of our work, but I won't go into detail. I'll now switch to the subject matter of today's discussion. And we call this a geolit receiver. And I'll explain to you why this is geolit. GEO stands for geostationary orbit. And this search and rescue receiver uses a geostationary satellite launched by ISRO. It's one of the, or many of the INSAT series of satellites. And geostationary satellite, do you know what's a geostationary satellite? Correct. I think you animated it very well. It moves at the same speed as Earth rotates. So which means wherever it is, relative to Earth, it stays where it is, right? So it is stationary. So you get a fixed coverage of an area. For it to be geostationary, it has to be several thousand kilometers, I think 36,000 kilometers from the surface of Earth. And from there, it can provide a lot of services to a fixed area. And one of the services we provide is the search and rescue. And the center in Bangalore, at ISRO's tracking center, which provides the services, is called Local User Terminal, LUT. So it's a geostationary satellite-based local user terminal called GeoLut, for which the receiver is developed by us. Now, this is a typical user scenario for a search and rescue system based on COSPAS SARSAT standard. So there's the satellite segment, let's say the geo satellites, and there's a receiving system here. And if there is some kind of emergency,